these videos, we will be looking at an introduction to a specific application of logistic regression that uses natural language processing. Because the data that we are working with is text data, which is canonically messy, this first video will focus on data quality. To begin, let's load the packages that we are going to be using today. In a previous exercise, we introduced the concepts of tokenization, stemming, lemmatizing, and stop words, assembling one unique function that cleaned text for us according to this NLP pipeline. So that's what the majority of these packages are for. So we begin by loading those packages and reading in the data. This data that I'm looking at is some product reviews that you could find on Amazon. Because the data that we're working with is new and we haven't seen it before, it's a good idea to take a look at what the columns look like and what the first handful of entries in the data look like. So let's look at what the columns look like by asking the reviews data frame for its column names, but we could also take a peek at the data by using this head method to see the first 5 rows of entries in this data frame. So one of the things that's really unfortunate is that the column headings are very inconsistently formatted. So there are some periods separating words. There's some capitalization that probably followed a schema, but since we only have this one column with this one capitalized R, that's going to be really difficult for us to remember. So one thing that I would suggest in terms of data quality is renaming some of these columns to have more simple and straightforward and meaningful column names. In order to do this, we're going to use the rename method of the reviews data frame. So we'll be using reviews.rename. And the argument to this function is a Python dictionary. And in short, a Python dictionary is like a list, but where the keys can be a different data type. In this example, we're going to have our keys be the previous names of the column headers, like we see down right here. And then we're going to separate those keys from the new value we want them to take on. And we're going to list this all between squiggly braces. So we need to tell it that what we're renaming are the columns, and we're renaming them according to this dictionary. So what was previously called reviews.doRecommend, that's the old name. We'd like to put a colon and then type what we want the new name to be on the right-hand side of that colon in between our string delimiters. So let's just call it recommend in all lowercase, and that's one of the renamings that we wish to do. We'll then put a comma there, and anything else we wish to rename can follow that same syntax. So while we're at it, let's take reviews.rating and rename that to simply rating. And let's take reviews.text and rename it just text. And last but not least, reviews.title can be renamed just title. And we hit Shift Enter, and it shows us those more straightforward column names. However, it's very important to note that if I rerun this cell after the renaming, nothing changes in the names of the column titles. This is because preserving data is a very important thing in Python. So before we make a permanent change, we might just want to see what the outcome of that change might look like to be sure that it's what we want. So all that's happened here in this cell 5 is it has shown me what it would look like if the renaming had occurred, but it has not actually made that change in the background, as evidenced by those old column names reappearing when I run the next cell. So if I am happy with the changes that it shows me right here, I have to communicate to the computer that I really want to make those changes permanent. So the easiest way for me to do that right here is to reassign the new value to the reviews object. And if I now run this cell, it does 2 things. First, it collapses the output. It no longer shows me what it would look like to make those changes, but it also actually makes those changes. So that's the first thing. We have this rename function that allows us to rename column headers to whatever format we desire as programmers. That's not necessary for the data analysis, but is very helpful for us and for our code readability. What is necessary for us in order to ensure a quality analysis is to take a look at the data and see just how much of our data is missing. In real-world data, you should expect for a lot of values to be missing in your data, and you should be aware of how much is missing from the get-go and make case-by-case decisions on what you want to do about that missing data. So our reviews data frame has this isNA function, which by itself just puts a true or false value everywhere based on whether or not it's an NA value. But we also have the ability to sum across columns in a data frame to tell us in all how many values are missing. So that's what this line of code does right here, and we can see the output is helpful in telling us that quite often, actually, we're missing a name. We're never missing a category of an object. Rarely are we missing a text or title, but that we are somewhat frequently missing this recommend column in our data. Now, these raw counts are nice, but a number like 6,760 might feel big or it might feel small to you. But what's much more important is how big or small it is relative to the number of reviews we have. So if we want to copy and paste this code and simply divide by reviews.shape at 0, remember shape tells us the number of rows and number of columns in our data frame. For us, we only want the number of rows, so we want the very first entry in the output of that shape object. Doing that division right here gives us these numbers translated as percentages of how much data we have in all. So, as I stressed before, very important when dealing with NA values to evaluate what NA values mean in the context of your program and also what you want to do about them. So there's lots of different things you could do about them. Maybe you want to throw out any data with missing entries. Maybe you want to fill it in with a different kind of vacuous thing so as to not be an NA value, but to be notably different. Perhaps you want to fill it in with an average. There are lots of different ways to handle NA values and absolutely no uniform rule. And in light of that, I think it's helpful for this example to walk through what my decisions are going to be about each of these various NA values. So my overarching problem that I'm going to be looking at with this specific set of data is I would like to take the information in the text column, which is the text that the reviewer has provided. It is their actual review of the product that was a free-form answer. And I want to use it to try to predict whether or not that user recommends the product. So my text data and my recommend data are the most important columns in this data frame to me. With that in mind, despite the fact that many of the products are missing a name, I'm not particularly troubled by the fact that they're missing a name. That's not an input that I'm necessarily going to be using to my function, and whether or not the reviewer would recommend the object could still be determined based on these numbers alone. So I'm not particularly troubled by these missing names, and I'd be perfectly happy to fill them in with a null string to indicate that they're not there, but to convert them away from NA values. Similarly, I'm not really using the title column, and so I'm not particularly troubled by these 6 missing titles. That's also a very small number relative to the number of reviews I have. So I'm not really concerned with those missing values. But really, I don't want to throw them away because there's still likely valuable data associated with those records. So for this specific case, I would choose to fill in the name and the title with null strings. So any column of a data frame, which is a series object in Python, will have this fillNA method associated with it, where this method is going to identify whether or not something is a null value. And in the situation where it is, it's going to fill the NA value with whatever value you put in between the parentheses. Here, I'm going to put just a single space, or I could put the null string there, and that will replace the NA values with string objects, which are what is otherwise found in that column, that are still notably empty. So this will convert them from NA values to actual string values so that they match everything else that's in the column, but we will be able to tell that there is no name for that particular object. The same issue here that we saw earlier in the video. If we didn't have all of this stuff over here on the left, all that would happen when we run the right-hand side of the equal sign is that we would be shown what it looks like with the NA values filled in with the null string, but it wouldn't actually make that change permanent in the reviews data frame in order to give us that preview of what our changes might look like. And so if we want to be very confident that this output is exactly what we want, and we want to keep those changes, then we need to add in this left-hand side of the equals. Now a very similar bit of code, we'll do the same thing with the title. I'll just replace name with title in both occurrences, and running these two cells will fill the NA values. So that's how I would handle this missing name and missing title. For the remaining three categories, the text, the rating, and the recommend column, this is a much bigger issue. If I do not have text, I don't have anything to go off of in terms of making my prediction towards a recommendation. And if I don't have a recommendation, I don't know in terms of training data whether or not the text that I was provided is accurately being predicted. So I couldn't use any of that data to train my model if it's missing this recommend column. And because I want the data used to train my model to be as accurate as possible, I am much more inclined to throw that data out given the small percentage of my data that falls into that category. So 594 by itself seems like it might be rather large, but it's actually about less than 2% of my data. The text, there's just one thing that's missing. So quite honestly, I'm not even throwing away 2% of my data. I can probably afford to throw it away, and throwing it away will ensure that the data that I'm using to train my model is absolutely pristine in terms of data quality. So while I filled in the missing name and title values, I'm much more inclined to take those reviews where I don't have a text or a rating or a recommendation and remove them. So this requires a different method, the drop NA method, where I'm dropping the NA values that only come from a subset of the columns. And the columns where I'm willing to drop something from, I then specify as a list to pass to this subset argument of the drop NA method. Same story, this side of the equal sign will show me a preview of what it is to drop those NA values. Then assigning the output of that preview to the original object makes the change permanent. And I've emphasized that by adding these print statements before and after we make the changes to review. So the first print statement is going to tell me how many reviews I have before I drop anything. And the second print statement is going to tell me how many reviews I have after I drop something. So executing that cell, you see the difference of about 600 things that I've dropped, which are coming from here.